In this problem, we're asked to figure out what a payment would be. You want to purchase a new car 9 years down the road, and you expect the car to cost $41,000. Your bank offers this plan with a guaranteed APR of 6.5%, and if you make regular monthly deposits. Now, how much should you deposit each month to end up with $41,000 in 9 years? So this is a savings problem where you're trying to save a certain amount each month to end up with $41,000 in 9 years. So for this one, we want to use that formula to compute that, which is the payment. That's the amount that you want to be depositing every month, is equal to the amount we want to end up with, A, times, and then we've got, for the top part of this fraction, the numerator, is the annual percentage rate. I'm just writing R instead of APR, over the number of times compounded in a year. That's over N, and that is being divided by, and here we've got two sets of parentheses, 1 plus R over N raised to the N times Y power, subtract 1, and then close. Okay, so in this case, I'm just plugging into that formula. So to find my payment, what I want to end up with is $41,000. And I'm multiplying this times this fraction, which is a complex fraction. So we've got 0.065. That's the APR written as a decimal, divided by the number of times compounded in the year. And the reason I know that's 12 is because we're asked to be making regular monthly payments. And then I'm dividing all that by two sets of parentheses, 1 plus the interest rate, 0.065, divided by the number of times compounded in a year, which is 12, raised to the 12 times the number of years that we're going to be saving, which is 9 years, minus 1. And when we plug all this stuff into our calculator, we end up finding out that the final payment is $280.35. Rounded off to the nearest cent. Now, to illustrate how to do this on the calculator, I've got to leave this drawing window here. So make sure you've copied down what we've written. And we're now going to go back over here to the right and type that into our calculator. So we've got 41,000 times, and then for our numerator part, in parentheses, 0.065 divided by 12, close parentheses, and I'm dividing all that by, and I've got double sets of parentheses here, 1 plus 0.065 divided by 12. All of that's closed in the first set, and I'm raising that. Oops, I need to go back. I didn't get the 0 in there. So let me insert that. Second delete allows me to insert 0.065 divided by 12, and I'm raising that to the 12 times 9 power. 12 times 9. And then to get off the powers, I've got an arrow to the right, subtract 1, and close parentheses. Okay, so all those parentheses are very necessary. And then when I key in enter, I get 280.35. I hope this has helped.